Hello, everyone. This is Amin. Today, I wanted to share a presentation that I did for Boston DevOps a couple of days ago. So this is SRE Demystified, where we're going to talk about site reliability engineering. So a little bit of a background about me. Why am I qualified to talk about this subject? So again, I am Amin Astani. I've been in the tech industry since 2005. I have a background in operations. This year, I launched my consultancy, Certomodo. I specialize in transforming tech companies using DevOps and site reliability engineering best practices. Prior to that, I worked at two companies. Most of my career was spent at Acquia. While there, I started and led their DevOps transformation for several years, as well as launched a site reliability engineering practice and team. Most recently, I was also at Meta, where I was a production engineer and a production engineering manager. While there, I led the reliability turnaround for a 20 plus engineering team that was responsible for building and operating an internal version of Heroku, basically. So simple backend services hosting, which ran 15% of all services at Meta. So a pretty awesome project. Basically, we're going to go over a few things. What is SRE specifically? It's an oft-used term, but what does it actually mean? Where did the term in practice come from? What are the original or the important concepts or terms that are often used in the space? Important practices, why it's important to adopt it, and then actually talk about the process of doing SRE, the actual interactions with engineering teams through engagements, and various pitfalls you can encounter along the way. So let's get started. What precisely is SRE? In a sentence, SRE is what happens when you ask a software engineer to design an operations team. That's what it is in a sentence. Who created this idea? This guy. This is Ben Trainer-Schloss. He is a VP of engineering at Google. He joined the organization in 2003 and was given a team of 7 engineers with the responsibility of running Google's web infrastructure. He took his background as a software engineer and applied it to this operations problem. The common books that people look at as a good introduction to SRE, it's these two. The one on the right is definitely more popular now because that was published by Google and you can get it online for free. But prior to that book, back in 2014, The Practice of Cloud System Administration was published. One of the co-authors, Tom Limoncelli, was a former Google SRE. So that was actually the book that I was reading when I was getting into this space. Though SRE predates the use of the term DevOps by roughly 5 years, when I reason about it, I tend to say that SRE is a implementation of DevOps with a specific focus on these things. So availability, latency, change management, incident response observability, those sorts of things. So let's get into the important concepts. I have a few definitions for you, and they're a pretty often used set of terms in the SRE nomenclature. So let's get right into it, starting with toil. So what do I mean about toil? Toil is the work involved in running a production service that is manual, automatable, it doesn't have any long-term value, and importantly, it scales linearly as the service grows. So good examples of toil would be incidents, firefighting, the incident response work, responding to alerts. You might have manual processes like service turn up or turn down, capacity planning. Those are the types of things you would consider toil. Now we have a few more terms that are all related to each other, and we'll just go over them step by step with some examples. So the first thing I want to introduce is the service level indicator, or SLI. In essence, what I am saying is there are certain aspects of your service that you're running that your customers are going to care about. Customers want your service to be up or available, and customers typically want your service to be fast, so have low latency. For a good example SLI, we have the 95th percentile of request latency for all read-only API endpoints over the past 7 days. So you can see that this SLI is very specific, which is really important because we're actually going to take that information and go into our data, like our logging or our time series, and generate a single metric that we can graph over time. So let's say we have that SLI in a dashboard. What do you do with that metric? We then create a goal or objective for that metric. So we have an SLO. So in essence, from that SLI, what values of that SLI are acceptable to the customer? So in our example, we're measuring latency of our read-only API. We want to keep that value below 500 milliseconds. And then finally, let's talk a little bit about error budgets. So for example, for SLI, let's say we looked at the dashboard and the current value of that SLI is at 300 milliseconds. Yeah. And well, since our SLO, our objective is 500 milliseconds, the difference between where we are and what our objective is 200 milliseconds. That is our error budget. An error budget is basically the amount of unreliability that the system can take on in order for your SLO to be violated. This is really important to note, and there's a couple of things to think about when we're talking about choosing SLOs and the resultant error budgets. Number one, error budgets are meant to be spent. So for example, let's say that we always have an error budget of an extra 200 milliseconds of latency week to week, month to month. There is a choice that we can make. We can ship more often, take more risks, and since we're committing to a P95 latency of 500 milliseconds, we can have our service be a little less reliable and be able to get more business value by shipping more features. That is totally acceptable. Another choice that you can make is you tighten your SLO and then offer a higher level of reliability to your customers. So again, error budgets are meant to be spent, and those are the two ways that you can do that. Another thing to really keep in mind is when choosing an SLO, you are trying to strike a balance between feature delivery and reliability. So if you have an SLO that is too tight, you'll be in a situation where engineers are getting alerted. They're getting woken out of bed for on-call. They're spending a lot of engineering effort on reliability. And there may be a point where it's not actually providing any business value. On the other side, you can have an SLO that is so loose that customers are complaining to the support organization and the engineering team isn't even aware of it. And then the engineering team is going to get involved anyway for incidents because customers are angry. So again, wisely choose your SLO that will strike a healthy balance between feature work and reliability. Okay, so we talked about the basic terms. Let's go into the SRE practices. What does it mean to actually do SRE? Well, according to Ben Traynor, we have these 12 practices. I'm not going to go over all of them, but basically there's a couple of things that I want to go over that is particularly important. In particular, number one here, hire only coders. Site reliability engineering is a software engineering discipline. We are using software engineering to automate away operational work. So it is very, very important that when we're doing SRE, we are hiring people that are able to write code and automate away tasks. Another item on the list that I think is really important is the last one. Postmortems are blameless and focus on process and technology, not people. I actually use that as a mantra for every postmortem that I have been in or have organized. I found that statement so profound that I use it everywhere I can. So yes, there's 12 practices. It's a lot to read, so I reduced it to 5, which I think are the core ideas around SRE. So we'll go over these. So operational responsibility, toil, on-call, we share that among the teams. So between SRE and SWE, or just across the team in general. And we try to manage that work using automation. So we're trying to eliminate it using code. Next, we measure customer success using service level objectives so that we have a empirical measurement of whether or not customers are happy. We use error budgets for decision making, so we know whether we should ship those new set of features. We know if the roadmap that we have planned is correct. We use error budgets to allow us to make sound decisions about what work the engineering team is doing. We learn from failure in a blameless way. Again, that is very, very important when dealing with incident response. And then finally, on-call rotations are properly staffed and humane. Their recommendation of having a on-call team with 8 people at one location or 6 people at each of multiple, I strongly agree with. And finally, on-call needs to be humane. So we're monitoring the amount of disruption the rotation is taking. We want to make sure there's a good work-life balance and we're not leading our engineers to burnout. So the one hot take I have for this presentation is if you are not doing all 5 of these practices, you're not actually doing SRE. And with that, let me go and do a little bit of story time with you all. So a few months ago, I was reached out to by a tech company on the West Coast. They had a senior site reliability engineering role open. They heard about me and they wanted to talk to me about the position and see if I was interested in applying for the job. As part of that conversation, I asked them about the responsibilities that the SRE role actually had in practice. And they said, oh, well, you would be responsible for operating the Kubernetes cluster, and you would be helping customers with debugging the performance of their code. I was interested in them elaborating on that, so I asked some follow-up questions about the on-call responsibilities and the support responsibilities. And they said that, yes, support would get, requests and tickets, and then support would escalate it to the site reliability engineering team when it was something that support couldn't handle. When I asked them that, hey, are software engineers involved in this escalation path too, they said no. So needless to say, my conclusion is that this role, while it said senior site reliability engineer on it, wasn't an SRE role, it was an operations role. So needless to say, I did not pursue applying for it. I find that really important to state because I want to make sure that folks that are interested in taking on SRE jobs are in fact applying for positions that are SRE rather than operations roles. So next, I want to talk a little bit about what the value proposition is for managers, directors, executive level of adopting SRE. Why should they do that? Because I think I've been selling it really well to engineering teams and individual contributors, but not necessarily to leadership. So why does this matter? Number 1, SRE reduces your operational cost. So if you are doing toil management, if you're automating away a whole bunch of work involved in the upkeep of the service, you now have the ability to operate larger and larger production systems without increase in headcount. So the goal that I set, or the way that I reason about it to people, is that we want to have a logarithmic relationship between the size of your infrastructure and the number of engineers required to support it. So that's number 1, reduction of operational cost. Number 2 is throughput. Again, if we are eliminating sources of toil, if we're eliminating operational risk, the things that cause outages and disrupt engineers, you now have more time to produce features. If you have more features out the door, you're able to please the customer, meaning more sales and more renewals. So again, the value prop is reduced cost and increased throughput, increased revenue. So I think that SRE allows organizations to really fill up their money bin. Okay, So now let's talk about engagement models. What I mean by engagement models is there's various ways that a site reliability engineering team can work with or engage with software engineering teams in order to get the job done. So let's talk about the first one, the classic one that was originally invented by Google. The way that this works is basically the software engineering team builds a service and then they hand off most, not all, but most of the operational responsibility to the SRE team. Now, this is a pretty good deal, assuming that, service level objectives are consistently met, we keep toil under control. You've now freed up most of the engineering team's time to continue to work on features. The one con to this is that, well, it does have a pretty high cost in terms of staff required to do this type of handoff, as well as the amount of time necessary to do preparation to make the service ready to hand off to SREs. So most teams aren't going to want to do this. It's not super practical. So there are several other alternatives that are pretty viable in the SRE space. The first one is a consulting model. Basically, you have a team of SREs that have their own roadmap. They have total control of their roadmap, but they are paying attention to the needs of the engineering organization, and they are doing whatever is necessary to help support them and what their needs are. So things like introducing postmortems, introducing SLOs, doing production readiness reviews, helping teams learn how to manage incidents properly. So all of these best practices or documentation or shared tooling, those sorts of things are really excellent work for an SRE team that is doing the consulting model. So the benefit, of course, is that they can serve the entire engineering organization and introduce SRE practices to them. But the major con of this is that they can't go deep with any one team. So they can talk about best practices, they can provide, tools and things like that, but they can't jump in and help them address a team specific or a product specific reliability issue. The other alternative is the embedded model. This is actually the engagement model that I have used the most in my career. I implemented it this way at Acquia, and at Meta, this is probably one of the most common engagement models that I've seen in the wild. So basically, you have site reliability engineers, and you embed them on engineering teams. They become a member of the team. They onboard. They learn how to contribute to the code base. They join the on-call rotation. They are doing the same work as the rest of the team. They are contributing to the roadmap. So the benefit of this is that the site reliability engineer now has in-depth knowledge of the product. They understand the code. They understand the processes. They're dealing with the team's pain and empathize with it. And through that empathy and being a member of the team and going through the same experience, it's easier for them to drive changes, champion, operational best practices, because they've built that credibility, because they actually understand what the team is going through. They're not coming in from the outside and recommending, change, right? So again, this is the most common one that I've seen. I find it to be very effective. However, there are some drawbacks to it. Number one, it requires ramp up. In order for a site reliability engineer to be able to contribute to the code base, be able to be on call productively, they need time to ramp up. Usually, I anticipate 3 to 6 months of initial investment in order for an SRE to be totally productive, which is an upfront cost for both the SRE and the team that they are joining. So that's something that has to be thought about when creating a new engagement. And then finally, there is a overhead in terms of a manager making sure that the engagement is healthy. They need to do one-on-ones. They need to be paying attention to the state of the team and keep lines of communication open so they can address issues as they come up. Finally, there's one more common engagement model that I have seen, which is the infrastructure team model. So basically, you have an internal platform or an infrastructure service that the engineering organization all depends on. you create a team of SREs and they go and build it. They have total control of the roadmap, and because they do, they're able to focus on reliability much more than other teams naturally would. A fringe benefit is that other teams are going to be able to have a good example of how software engineering can be done with a reliability focus. Of course, again, a couple consequences of that, a couple of cons. There is limited scope. If you're putting your SREs on this one team, they're not able to easily expand their influence to the entire engineering organization. And without organizational buy-in and support, without clear boundaries and scope for what this team is doing, it is very easy for this team to devolve into an ops team, just doing like toil and incident response for the services that they've built. So again, very useful engagement model, but it does have some risks. Okay, so now we know the various ways that you could interact with engineering teams through engagement models. So let's say we want to start engagements. How do we go about doing that, especially when it comes to the embedded engagement model? So here are a few tips. Number one, know who your customers are. So what I mean by that is for every given software engineering team, you're going to have a product owner, you're going to have an engineering manager, you're going to have a tech lead. Those are the people that you're going to want to make sure that they are happy, that you're taking in their feedback, and that you're in constant communication with them to make sure that the state of the engagement is in good shape. Before starting an engagement, it's really important to do some initial discovery. One of the practices I use is something called a production readiness assessment, where when I start on a team, I'm basically covering all the bases. How are they doing incident response? How are they doing change management? Are they doing capacity planning? Those sorts of things. And getting that background on how mature a team is across all the various operational responsibilities gives me an idea of what they need to work on, which then leads to the next item, creating an engagement document. It doesn't have to be super formal, but you can just have a doc that says, okay, this SRE is going to be on this team for at least this period of time, and they're going to introduce service level objectives, they're going to improve observability, they're going to reduce the amount of alerts that a team or on-call rotation is sustaining. So setting clear expectations about what the activities and the goals of what the SRE is on the team is really, really a good idea. It allows you to hold everyone accountable. It's a good practice. Again, make sure you allow time to onboard. It can take 3 to 6 months for the embedded model if you're embedding an SRE on a team. Pull for feedback. Once again, I mentioned this before. Do one-on-ones with your customers. Even do one-on-ones with individual contributors on the team that the SRE is embedding on, just to make sure that things are going well, that the SRE is enabled, and that they're building credibility and respect in the team, because that's actually really important to drive changes. And then finally, evaluate the engagement periodically. And what I mean by that is SRE engagements don't last forever. There are many reasons why it no longer makes sense for an engagement to continue. For example, the system can be much more reliable. The team may be able to run the service by themselves. There might be other teams in the organization that have more critical needs. The service that the SRE is helping supporting is being deprecated, and therefore it doesn't need an SRE presence. So there's a lot of reasons why keeping an engagement going no longer makes sense. And it is our responsibility to make sure that our SREs are in the right place at the right time, doing the most important work. And then finally, let's talk about a few pitfalls that I've encountered over the years as an SRE or as an SRE manager running engagements. Number one is when you have a SRE embedding on a team, it is very common for there to be discussions about, hey, this is SRE work or this is SWE work, and having discussions about how to split up the work so that way SREs are doing SRE things and SWE are doing SWE things. That's not a good perspective, in that, remember, SRE is all about sharing operational work with SWE. So when this happens, I tend to speak up and say, hey, There's no difference between what a SWE is doing and an SRE is doing ideally, and encourage and incentivize SWE to participate in operational work. When I was at Meta, we had teammates that were doing really cool things like load testing, doing write-ups for past incidents, taking action on follow-up tasks from past incidents. It's really, really important because eventually the SRE will leave the team, and SWEs will need to be able to run the service on their own. So there is no such thing as SRE work versus SWE work. It's just all everyone's work. Another breakdown is having on-call responsibility not being shared. When I was at Meta and I started my first big engagement there, because it was a team of 20, they thought that, hey, we should only have an on-call rotation of like 6 or so people because otherwise people would not be on call enough for them to have context of how to be on call and to be productive during the shift. While that argument is true, the consequence of that is that most of the team was not in touch with the operational reality of running the system. So when I joined the team, I helped restructure the on-call rotation, basically making 2 on-calls so that everyone could be on call. They were all in touch, and then there was a shared sense of empathy about the on-calls experience as well as the customer's experience using the service. Thirdly, and probably one of the big ones you have to watch out for, is where SRE practices aren't being followed. So basically, they're not following the plan. You can have a situation where an SRE is focusing on feature work so much that they're not championing the reliability work. I've seen that happen. I've seen it where there's so much pressure on the engineering team to deliver features that they aren't really prioritizing the SLOs. They're not prioritizing reliability improvements. And, these things can happen, and we have to, assume good intent. But when these things take place, it's important to have conversations with your stakeholders and customers and figure out what's going on and figure out how to course correct. And there may be situations where you can't, at which point you end the engagement. And then finally, when embedding SREs on a team, make sure that they are included in all of the meetings, all of the chat rooms, all of the shared Google documents, because it is very common for SRE to not be included in communications naturally. So you need to make sure that it's happening from the start in order for them to be able to integrate with the team and provide value. So we covered a lot of ground here. This is a YouTube video, so there is no Q&A. But basically, we talked about what SRE means, where it came from, its practices, its common terms, how to run engagements, and what the pitfalls are. I hope that you enjoyed this video and learned something about site reliability engineering. Again, my name is Amin Astani. I run a consultancy called Cherdomoto, where I help teams with their reliability posture. I'm very interested in talking with you. If you need help with this, you can go and check out cherdomoto.io. I have a lot of interesting articles there about site reliability engineering and DevOps, and I am looking forward to hearing from you. Thank you so much.